So we'll continue with the chapter chemical reactions. We have studied about the different types of chemical reactions, that is combination reaction, then decomposition reaction, displacement reaction, and double displacement reaction. In any type of reactions, chemical bonding takes place. So whenever a compound is formed, a chemical bond is formed between the elements that form the chemical bond. So today we will be learning about how these bonds are formed. Chemical bonds are of two types: electrovalent bond and covalent bond. Electrovalent bond occurs between a metal and a non-metal, and covalent bond forms between two non-metals. Today we will be discussing about electrovalent bond. That means a bond formed between a metal and a non-metal. Today we will be discussing about the electrovalent bond or ionic bond, and I've already told you electrovalent bond is always formed between a metal and a non-metal, and we have already learned by using the valence electrons how to find out whether a given element is a metal or a non-metal. If you remember, if the valence electrons, that means the number of electrons in the outermost orbit, is 1, 2, 3, it is a metal, and 4, 5, 6, 7 is a non-metal. So this electrovalent bond is always formed between a metal and a non-metal. So let's do the first example. Sodium, the bond formed between sodium and chlorine. We know the atomic number of sodium is 11. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, and sodium. So the atomic number of sodium is 11, and similarly the atomic number of chlorine is 17. Now we already know that atomic number is always equal to the number of electrons. We know that atomic number equals to number of protons, which in turn is equal to the number of electrons. We've already done this. So if atomic number of sodium is 11, number of protons is also 11, and number of electrons is also 11. Similarly, if the atomic number of chlorine is 17, number of protons is also 17, and number of electrons is also 17. Now let's write the electronic configuration. Sodium, since the number of electrons is 11, first orbit 2, second orbit 8, and the last orbit 1. Chlorine 2, 8, 7. This we have already learned how to do. So by looking at the valence electron, 1, 2, 3 is a metal. That means sodium is a metal. And 4, 5, 6, 7 is a non-metal. So chlorine is the non-metal. Now we have to draw the orbital structure diagram. I'm doing freehand, but you'll use a compass to do it. So number of protons is 11. So this is the nucleus. In the nucleus we have both the protons and neutrons. Here we'll just write the protons. Then the first orbit, second orbit, and the third orbit. This is for sodium. Okay, I'll write this with pen. Similarly, chlorine, protons is 17. First orbit, second orbit, and the third orbit. You will use a compass to do it. I'm just doing it with free hand. Oh. Okay, I'll use two different colors. So you will do the same. For sodium, I'm using pink. 2, 8, and 1. Chlorine, 2, 8, and 7. Now we know that for any element to be stable, the outermost orbit should have 8 electrons, like noble gases. Noble gases, they have a stable configuration because the outermost orbit has 8 electrons. So whenever a bond is formed between a metal and non-metal, what happens is a metal always gives away electrons and the non-metal always accepts electrons. Now see, sodium has only 1 electron in its outermost orbit. If it gives away this electron, this orbit will vanish. Only 2 orbits will be there and this orbit will have 8 electrons. That means sodium, if it gives away this electron, it will become stable. Similarly, chlorine has 7 electrons in its outermost orbit. If it receives 1 electron, it will have 8 electrons in its outermost orbit and it will become stable. So what happens is metals always gives, non-metals always accepts. So now see this. So now sodium will give away its electron to chlorine. So it has 1 electron in its outermost orbit and this electron it will give to chlorine. Now see what happens after that. This is the atom. Protons, even if the electrons are given away, the number of protons remain the same. Now sodium has given away 1 electron. If you see this, there were 3 orbits. Now it has given away 1 electron to chlorine. That means this outermost orbit now disappears. So now it will have only 2 orbits. Similarly, chlorine it will have all the 3 orbits because it has received electrons. It was 2. Initially, chlorine was 2, 8, and 7. And it received 1 electron from sodium. So this pink electron it received from sodium. Now what happens? Once a metal gives away electrons, now it forms ions. IONS. It forms ions. Since sodium has given away electrons, it gets a positive charge. And how many electrons did it give? 1. So that means it will get 1 positive charge. So metals give, and when they form ions, they become positively charged. Chlorine, it received electrons, so it will be negatively charged. And how many electrons did it receive? 1. So 1 negative charge. So depending on how many electrons a metal gives, it will form that many positive charges, and non-metals, depending on how many electrons it receives, will form that many negative charges. So now this compound which is formed by these two ions, Na plus Cl minus. These two ions will combine to form a compound known as NaCl. So directly metals and nonmetals do not react. First they will form a stable configuration. Metals will always give away electrons and nonmetals will always receive electrons. Here if sodium gives away one electron, this outermost orbit will disappear and it will have 8 electrons in its outermost orbit, becoming stable. Similarly, chlorine, if it receives 1 electron, the outermost orbit will have 8 electrons, making it stable. So sodium gave away 1 electron. These two formed ions. Sodium became positively charged since it gave electrons. Chlorine became negatively charged because it received 8 electrons. Now they are stable. Now they will form a compound. So sodium ion and chlorine ion will form a compound known as sodium chloride. So in an electrovalent bond, ions are formed. That is why it is known as ionic bond. And I told you metals always give away electrons and they form a positive ion. Non-metals receive electrons and they form negative ions. So positively charged ions are known as cations and negatively charged ions are called anions. So metals form cations and non-metals form anions. Metals give away electrons and form cations. Non-metals receive electrons and form anions. Let's do another example, magnesium and oxygen. So let's see the periodic table once more. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium and magnesium. So the atomic number of magnesium is 12 and similarly the atomic number of oxygen is 8. We already know atomic number equals to number of protons which is equal to the number of electrons. So if it is for magnesium, atomic number is 12. So number of protons will also be 12. Number of electrons will also be 12. Oxygen, atomic number 8. Number of protons 8. Number of electrons 8. Now we come to the electronic configuration. Magnesium 12, so 2, 8, 2. Oxygen 8, so 2, 6. Outermost orbit 2. 1, 2, 3 is a metal, so magnesium is a metal. 4, 5, 6, 7 non-metal, so oxygen is a non-metal. So magnesium will give away electrons, oxygen will receive electrons. Let's draw the orbital structure diagram. I'm repeatedly telling you all, I'm drawing it freehand. I want you all to use a compass. So 1, 2, 3 orbits. This is oxygen. Number of protons 8. Only 2 orbits. So again I'll use pink and green. This is magnesium atom and this is oxygen atom. So 1, 2, 3, 4, 6, 7, 8 and the outermost orbit has 2. Oxygen, atom of oxygen, 2, 3, 4, 5, 6. So as I've explained, magnesium also has to has to form ions by giving away electrons, so that the outermost orbit has 8 electrons, and oxygen will form ions by receiving electrons, and so that its outermost orbit will have 8 electrons. That is stable configuration. Now see, magnesium has 2 electrons in its outermost orbit. If it gives away these 2 electrons, this outer orbit will vanish, and so the outermost orbit here will have 8 electrons. And oxygen, if it receives 2 electrons here, will have 8 electrons in its outermost orbit. So oxygen needs 2 electrons to form a stable configuration, and magnesium has to give away 2 electrons to form a stable configuration. So here magnesium is giving its electrons to oxygen. So nucleus, even after giving electrons, the number of protons will remain the same, that is 12. Now since the outermost orbit is not there because it has already given away electrons, now it will have only 2 orbits. And this is for oxygen, 2 orbits. So 2 and 8. So it has formed a stable configuration by giving away 2 electrons. Similarly, oxygen also has formed a stable configuration by receiving, since it has received 2 electrons for magnesium, I'll use pink color here. Now as I've told you, once magnesium gives away electrons, now it is no longer an atom, it forms an ion. And since it has given away electrons, it becomes positively charged. But how many electrons did it give? 1, 2. So it will form 2 positive charges. And oxygen, since it has received 2 electrons, it will be negatively charged. And how many negative are there? 2 negative charges. So an atom has formed an ion. Metals by giving away electrons, and non-metals by receiving electrons. That is why electrovalent bond is also known as ionic bond. So now, as I told you, now these ions will now react with each other to form a compound, magnesium oxide. So always remember, electrovalent bond is formed between a metal and a non-metal. Metal gives away electrons, non-metal receives electrons. They cannot give as many electrons they want. Actually, they have to remove this outermost orbit so that they form a stable configuration. So they always give away the valence electrons. And the non-metals also, they receive only those many electrons that they require to form a stable configuration. Here they needed 2. Here they need this chlorine needed only 1. So depending on how many electrons it needs to form the stable configuration, it will receive that many electrons. Metals form positive charges. Non-metals form negative charges. Depending on how many electrons it gives away, that many positive charges, and how many it receives, that many negative charges. Since ions are now formed, ions will react to form the compound. Now let's do one more example. Let's take again magnesium, and this time let's take chlorine. We have already done magnesium atomic number 12, chlorine atomic number 17. Atomic number equals to number of protons, which is equal to the number of electrons. So magnesium 17, sorry, I'm so sorry, 12, chlorine 17. Now the electronic configuration. Magnesium 2,8,2, chlorine 2,8,7. So this is a metal and this is a non-metal. Protons 12, so 3 orbits. Protons 17, again 3 orbits. Two, 8, 2. Two, 8, 7. This is the magnesium atom and this is the chlorine atom. Now see here, magnesium needs to give away 2 electrons so that this orbit vanishes and it has 8 electrons in its outermost orbit. Whereas chlorine can receive only 1 electron so that it will have 8 electrons in its outermost orbit. So magnesium gives away 1 electron to this chlorine atom. So now what happens to the another electron? So what happens is another chlorine atom will also be required. So here, how many chlorine atoms are we taking? 2, but only 1 magnesium atom, because magnesium has to give away 2 electrons, but chlorine atom can receive only 1 electron. So magnesium will give away its electrons to 2 chlorine atoms. This is also a chlorine atom. So this electron will be given to the second chlorine atom. So as we know, an ion is formed magnesium now will have only 2 orbits because the outermost orbit has vanished. So this is the first chlorine ion and this is the second chlorine ion. So 2 and 8. This is stable. 2, 8, and it had 7 electrons in its outermost orbit. It received 1 from magnesium. Similarly, the another chlorine atom also. It received 1 from magnesium. Now this is no longer an atom but an ion of magnesium. And how many electrons did it give away? 1, 2. So 2 positive charges. This chlorine atom, how many negative charges will it have? Only 1, because it received only 1 electron. Similarly, this chlorine ion also received only 1 electron, so it has one negative charge. So the last step, the magnesium ion now reacts with the two chlorine ions to form MgCl. But how many Cl are there? 1, 2. So MgCl2. So magnesium reacts with two atoms of chlorine which later forms ions to form magnesium chloride, MgCl2. So magnesium ion reacts with two chlorine ions to form MgCl2. Cl2 because there are two chlorine atoms that have been used. So I hope you all understood what was done today. Thank you everyone.